Hey everyone, and welcome back to section 5.2. Before we get to multiplying polynomials, I just want to talk real quick about scientific notation and what that is. So a number is said to be in scientific notation if it looks like a number times 10 to the n, where that number is between 1 and 10, and n is an integer. You might see it on your calculator as something like this. So what this really is just a way to compress really big numbers. Numbers with a lot of digits or decimal places. For example, we have this right here. This is the distance equivalent to 1 light year in meters. And so that's a pretty big number, and it's so big that it's even hard to conceptualize, but we can convert it to scientific notation, which makes it a whole lot less cumbersome. So instead of that entire number, we would say something like approximately 9.46 times 10 to the 15 power. Or perhaps on your calculator, you would see it as 10e15. Or sometimes even just e15. And for another example, and kind of the other extreme, this is 1 atomic mass unit in terms of kilograms. You can take this to be the mass of hydrogen, for examples. So 1 atomic mass unit in kilograms is really 1.66 times 10 to the negative 27, which takes up a whole lot less space. All right, so I'm going to talk about how to go from our normal notation to scientific notation. So here are two numbers, and we want to convert these into scientific notation to make them a bit more compressed. So for both of these, what we're going to do is move the decimal place until there's only one digit directly to the left of the decimal point. So for the left-hand number, since it's a whole number, I remember that my decimal point is all the way after the last digit, and I have to move 2.067. And for the right-hand number, I want to move my decimal to the right. So I'd have 8.98. And then what we want to do is count the number of places that we move the decimal point. Well, for the first number, we moved 6 places. And for the second number, we also moved 6 places, but we moved in a different direction. And finally, you want to ask yourself, what direction did the decimal point move? If you're moving the decimal point to the left, your exponent's going to be positive, but if you're moving it to the right, your exponent is going to be negative. So some examples, we want to convert these to scientific notation. So for the first number, I move 1, 2, 3, 4 places to the left. So I'd end up with 3.7 times 10 to the 4. Okay, how about the next one? I would move 1, 2, 3 places to the right to get 5.2 times 10 to the negative 3, because I moved to the right 3 places. For the third number, again, I moved 4 places to the right, so I get 4.83 times 10 to the 4th. And lastly, since we moved 2 places to the right, I'm going to get 1.29 times 10 to the negative 2. And say we want to go the other direction from scientific notation to our standard decimal notation. So to do that, when you see a positive power, you want to move the decimal right n places and move the decimal left n places when you see a negative. So this is opposite what we were doing when we converted from decimal notation to scientific notation. So for the first number, 6.386 times 10 to the 5th would be, of course I have to fill in zeros, but I get 638,600. And for the negative exponent, I have to move to the left 3 places. And there we have the conversion. It's not too bad. From here, we can also define a way to multiply and divide numbers in scientific notation. And for that, you're just simply applying the rules of exponents. So, for example, negative 4 times 10 to the 5th times 2 times 10 to the negative 7. You're multiplying these two numbers together, the negative 4 and the 2, which would be negative 8. And then you're multiplying together 10 to the 5th and 10 to the negative 7, which means you are adding the exponents. So you get negative 8 times 10 to the negative 2. Same deal with division. 9 divided by 3 is 3. And then we are going to be subtracting exponents. So I'd have 10 to the 3rd minus negative 3, which is equal to 3 times 10 to the 6th power. And there we have it, scientific notation.